Okay, students, so second part of day 7 is velocity problem solving. So we're going to go through some examples from our velocity slideshow. All right, some example problems here. And then we have some practice problems on velocity that are here. All right, so we'll work on those. So here we go. Okay, here goes our first problem. Anthony runs 10 kilometers west and then turns around and runs 6 kilometers east. The run takes 1.33 hours. We want to figure out Anthony's speed and then his average velocity. So for this problem, we're doing both because I want you to get a comparison between speed and velocity. All right, so this is example 1. So for part A, my givens. Yikes. All right, so my givens, I know that he goes 10 kilometers west. He goes 6 kilometers east. All right, these are all distances. And I know that the time for the whole thing is 1.33 hours. My unknown is speed. Equation for speed. Speed equals distance over time. I'll substitute. And I'll get that speed is going to equal, so the total distance is going to be 10 plus 6. So that's 16 kilometers divided by 1.33 hours. And then solving, speed is equal to, sorry, this is kind of messy, 12. So I get 12 kilometers per hour. Again, I only get one significant digit because these both have one significant digit. Even though the time has 3, these both have 1. And so I have to round this to 10 kilometers per hour. So that's the answer for speed. For part B, we want to find the velocity. All right, so our unknown is, what is velocity? Velocity is a vector. We haven't talked about this yet, but vectors actually get this little arrow on top to show that they are vectors, that they have direction. So think of that pointing arrow reminding you that there's a direction. Okay, equation. So for velocity, it's equal to displacement over the change in time. All right, so change in position over change in time. My unknown is going to be, I'm going to substitute, excuse me. So substituting, well, I need to know what the displacement is. So before I can substitute, I need to know what is the displacement. So he went 10 kilometers west and then 6 kilometers east. So that looks like this. West is to the left on a map. So that'd be 10 kilometers west. And then from there, go back 6 kilometers east. So about to here, right? So what's left? What's this distance here? What's left over? It's 4 kilometers. So we call this the resultant when you add together two vectors. And so the resultant would be this thing, 4 kilometers. And which way is that? It's west. So that'd be the result, all right, or the net. All right, if you think about like net pay, all right, it's the result of how much you earned minus taxes and insurance and investments and stuff like that. Okay, so this would be 4 kilometers west. That's the displacement. And the time is 1.33 hours. And now I can solve. So my velocity is going to be equal to whatever this is. And actually 1.33, you might know that's 4/3. So if you do 4 divided by 4/3, the 4's end up canceling, and you actually ended up with 3, exactly 3. So this is 3 kilometers per hour west. That is his net velocity. Or just his velocity, sorry. So that's the answer there. You notice that these two things are really different. All right, this is how fast he was going. All right, to one significant digit, 10 kilometers per hour. But this is his velocity, and it's very different because of the displacement, right? He went back towards where he started, and so his net change wasn't very far. Right? He definitely was going pretty fast, but because he went back towards where he started, his velocity, which is an average, went down. Okay, so that's the first one. Example number 2. All right, how long would it take David to go from Van Nuys to Long Beach if David traveled the 50 miles at an average velocity of 35 miles per hour, southeast? Okay. So my givens, I know that the Van Nuys and Long Beach stuff doesn't matter, but I know that his displacement is 50 miles. I know that it's southeast, so I'm going to write SE for southeast. And I know that his velocity is 35 miles per hour. That's also southeast. And I want to find how long. What's that mean? Time. Okay, so equation to do this. So we know that velocity is equal to displacement over, what do you call it? Displacement over time. And so we can rewrite this for time by switching the places of these two things. We talked about this in the last video. If we wanted to solve for time, we'd multiply both sides by time and divide both sides by velocity. And so we get that time, which is a scalar, so it doesn't get a little vector hat, is equal to displacement over velocity. Okay, so I can plug these in because I know these things. So let's do that. I'm just going to write time because our initial time is going to be 0, so I don't need the delta. And so this is 50 miles southeast over 35 miles per hour southeast. And you'll notice that a few things go away here. Miles cancel, the southeasts go away, and you're just left with hours in the denominator of the denominator, which moves on up to the numerator. And so we get, when we solve, we get 50 over 35, and then whatever that is in hours. So what's 50 over 35? It is 1.42, and that's all we got to do. Hours, again, because of the 50, we only get one significant digit. And so what's our answer going to be here? Well, so we'll get, we'll have to cut here, right there. And so time is going to be equal to 1 hour. That's all we can say. Can't be any more specific than that. All right, let's do example 3. This is our last example. Here we go. Finally, we get something with more than one significant digit. Yay. If Jonathan travels an average velocity of 75 kilometers an hour for 3.4 hours to the Santa Monica Pier, what's his displacement? Okay. Givens. I know velocity is 75 kilometers per hour I know that time is 3.4 hours. That's a bad 4. My unknown would be the displacement equation. Okay, so I want to know displacement. Again, I know velocity equals displacement. Displacement over time. So if I want to solve for displacement, I have to move time to the left-hand side, and I end up with displacement equals velocity multiplied by time. I hope you're feeling okay with all of these symbols. This is what you get in algebra and beyond. You get lots of symbology like this, and then you rearrange those things and then plug in numbers kind of near the end. This is how it's usually taught. If you have questions about this, feel free to ask them. You can send me a picture of something if you're stuck on it, right? I'm confused right here. I don't know what happened. Or you can look at this video and say, Mr. Alexander, at 11 minutes and 10 seconds, I got lost. Can you explain what you did there real quick? And I will. Okay, so this is the equation. So I'm going to substitute delta x equals, I know the velocity. It is 75 kilometers per hour. I feel like I'm missing something. Oh, west. There we go. So that's west. And I'm going to put this in parentheses because there's a lot of stuff here, and I want to show that I'm multiplying. So remember, parentheses indicate multiplication. So here we go. I got to multiply these numbers. So 75, I can't do this in my head, times 3.4 is 255. Woo. Okay, solving. Delta x equals 255. 255, what? Well, the hours cancel. And so it's kilometers west. How many sig figs? There's 3. I'm only allowed to have 2. Both these have 2. So my answer is going to end up being that the displacement is equal to, and I'm writing this kind of small, sorry, it's going to be, my cut is here. This ends in a perfect 5 again, so I have to choose, do I round? I have to round to the nearest even. So that's either going to be 260. All right, the thing that I'm rounding has to be an even number for statistical significance, or down to 240, right? 4 and 6 are my even numbers. So which one's closer? 260 is definitely closer. 260, and that's kilometers west. This is the answer to 2 significant digits. All right, so that is all the examples. And I'm going to stop this video here, and then I'll make one more that goes over all of the velocity problems from the speed and velocity worksheet.